We're solving problem 16 from the 2020 equals MA exam. A bead attached to a string of length L equals 10 meters is released from a very small angle theta of 0 to the vertical. A wall is placed in the path of the bead such that the bead collides elastically with the wall when the string is at an angle theta over 2 to the vertical as shown. What is the time interval between the bead's collisions with the wall? So this is a figure depicting what we have here. This is it's swinging to the maximum point there. It's not quite drawn to scale, but because I can't draw good. But we have this length here, which is 10 meters. 10 meters. And has a mass of m. Yeah. So it has mass m. That matters. And then this angle from the vertical is theta of 0. And there's a wall here on one of the sides where the angle there, when it hits the wall to the is theta 0 over 2. So we want to find the time period, and basically what we want to do here is we can write that theta of the time is equal to theta of 0, that's our angle, times cosine of omega times time. And this is simple harmonic motion. And this is the case where omega is equal to the square root of the force of gravity over the length of the string. So, since conserving energy here, we can this left side to be equal to negative theta of 0 over 2 is equal to theta of 0 times cosine of omega times time, because it's moving this. These theta of 0's cancel out, and what we get from this, cosine of omega times time is equal to negative 1/2. So now we have this, we can effectively get rid of the cosine, taking the arc cosine of both sides. So omega of time is now, well, this side is now 2 pi over 3. Since we know that omega is the square root of g over L, our time for the walls in this case, and we're doing the walls, or equating it to the walls because we separated this angle. So this is equal to 2 pi over 3 times the square root of L over G. But we want the time between the collisions. We know that the length where it's like not colliding with the wall, 2 times of the angle where it is colliding with the wall. So it's 2 times the time. So the time is 2 times the time it takes for the wall part. And this is 4 pi over 3 times the square root of L over G. The length is 10 meters. 10 meters divided by 10 meters per second squared, because this test wants us to approximate G equals 9.81 to G equals 10. So this just effectively cancels out to 1. So our answer for this problem is 4 pi over 3 seconds.